This video is going to be on how to write numbers as products of prime factors. Looking at this first question, it's asking me to write the number 700 as a product of prime factors. Now, what does this actually mean? Well, the word product means times. Okay, so if I was to ask you to find the product of two numbers, I'll be asking you to times those two numbers together. Now, that means that what I'm going to do is I'm going to be writing this number 700 as a whole list of numbers that when timed together give me 700. Okay, now these numbers are special kinds of numbers, as you can tell from this next little section. Okay, here, prime factors, they are the prime numbers. Now, if you don't know your prime numbers, then I suggest you learn them. I'm going to write them out now, and I suggest that you learn the first 10, because most of the time that will be sufficient for you to be able to answer any of these questions. So the first 10 prime numbers are 2, 3, 5, 7, 11. Notice I didn't have 9 there because 9 can be divided by 3. 13, 17, 19, 23, and 29. Right, so how do we actually write this number 700 as a product of prime factors then? What we do is we draw a factor tree. And we start off with 700. And first off, we're going to look at what numbers divide 700. Now, I would always suggest that you start with the lowest prime number first, which is 2. So we're going to look at whether 2 divides 700. And hopefully, you can already tell that it does. 2 divides 700 350 times. Now, at this stage, I'm going to circle any of these numbers I've just come up with if they are prime. Now, I know that 2 is prime, so I'm going to circle that number. 350 is not prime, so I'm going to carry on this tree from 350. So again, I'm going to ask, does 2 divide 350? And again, yes, it does. 2 divides 350 175 times. Again, I'm going to circle the 2 because it's prime. I'm going to carry on with 175 because it's not prime. I'm going to quickly say in my head, does 2 divide 175? No, it doesn't. And I'm going to move on to the next prime number, which is 3. Okay, I'm going to quickly think about whether 3 divides 175. And after thinking about it a little bit, hopefully you've come to the conclusion that it doesn't. So now I'm going to move on to my next number, which is 5. Now, because 175 ends in a 5, yes, it is in the times table, so I can divide it by 5. And 175 divided by 5 is 35. Again, at this stage, I'm going to circle the 5 because it's prime, and I'm not going to circle the 35 because it is not prime. Again, I'm just going to quickly think, does 35 divide by 2? No. Does it divide by 3? No. Does it divide by 5? Yes, it does. 5 divides 37 7 times. And again, at this stage, I'm going to circle any numbers that are prime, and 5 I already know is prime. And if I look in my list, I'd see that 7 is also prime. So now that I've circled all of these numbers down the bottom, I can't actually continue this tree diagram. So all I need to do is write my answer out, which is going to be this list of numbers all times together. So that is 2 times 2 times 5 times 5 times 7. Now, unfortunately, that is not enough to get all the marks on your exam. Instead, we've got to write it in what we call indice form. So this means that any numbers that are times by themselves, we need to write to a power. Now, hopefully you remember that a number times by itself is squared. So you can see here that we've got 2 times 2, which is the same as 2 squared, times 5 times 5 is also 5 squared. And 7 doesn't have anything times by itself, so it's just left as 7. Again, if I had 3 2's there, I'd have a power of 3. If I had 4 5's there, I'd have a power of 4 at the top. Okay, so this is sufficient to get all my marks there. Okay, so I've got a question on the board here, which is very similar to the question that I had before. Okay, it is also actually asking me to write the number 1700 as a product of its prime factors. Now hopefully you can see in the question that this bit here looks very similar to our answer in the last question. So what we're going to do is we're going to write 1700 as a product of their prime factors, and hopefully we'll get a whole load of 2's, a whole load of 5's, and another number which I don't know, which they've called C here. So before I start, I'm going to need all of my prime numbers again. So I'm just going to list those out again. Now that I've got my prime numbers, I'm going to now start my factor tree. So 1700, first off, does 2 divide it? Yes, it does. And 2 divides it 850 times. Circle the 2 because it's prime. Does 2 divide 850? Yes, it does. And this time it's going to be 425. Now, 425 doesn't divide by 2, and it doesn't divide by 3, but it does divide by 5. And that does that 85 times. Circle the 5 because it's prime. Now does 2 divide 85? No. Does 3 divide 85? No. But 5 does. And 5 divides 85 17 times. Now checking in my list again, I already knew that 5 was prime, but also hopefully you can see that 17 is also in my list. It's also a prime number. So again, I'm going to write this out, just like I did before, 2 times 2 times 5 times 5 times 17. But remember, I've got to write it in indices form, so that is 2 squared times 5 squared times 17. So looking at this form that I've circled at the top here, that must mean that A is the number 2, B is also the number 2, and C is the number 17. Now, after asking you to write numbers out as product of prime factors, they might ask one of these two questions, which is asking for the highest common factor of the two numbers, or asking for the lowest common multiple of them. Now, we can use prime factors to find these, especially if the numbers are very big. So how do we do this? Well, what we do is we use a Venn diagram. So here's my Venn diagram. I hope you can see that there are two circles with one part overlapping the other part. Now what I'm actually going to do here is I'm going to write all of the prime factors of 700 and 1700 into these different bits of the Venn diagram. Now I'm going to start off with a pit in the center. Now these are all the factors that are in both. If you remember from the last example, okay, 1700 had a 2 squared and a 5 squared, and also the example before that, I had 700 also having a 2 squared and a 5 squared. So that means that they share a 2 squared and a 5 squared. Now hopefully you can remember that 700 had an extra factor which was 7, and 1700 had an extra factor which was 17. So how does this Venn diagram help me to find the highest common factor of both of these numbers? Well, the highest common factor is the product, if you remember the product meant times, of all the numbers in this center section here. So what I can do is I can write the highest common factor of 700 and 1700 equals 2 squared times 5 squared. And if you remember, 2 squared is 4, 5 squared is 25, so 4 times 25 is 100. So the biggest number that divides both 700 and 1700 is 100. Now, how can I find the lowest common multiple of these two numbers? Well, it's going to be very similar to the highest common factor, but this time I'm going to find the product, remember that means multiply, of the entire Venn diagram. So that is the center part, which is the highest common factor, times the 7 from the 700 and the 17, which is left over from the 1700. So I'm going to write out lowest common multiple of 700 and 1700 equals, well, it's the numbers in the middle, which we calculated was 100, times 7 times 17, which equaled 11,900. So hopefully that video has helped you to understand what it means to write a number as a product of its prime factors. Okay, so again, I would suggest that you practice this and just recap just before your exam what this phrase means. And definitely remember how to find highest common factors and lowest common multiples using this method of prime factors. Okay, good luck.